Okay, well, thank you everyone for joining us today. We're here to discuss edge computing and 5G together with Hub Security's very own CTO, Andrei Iaremenko, alongside Jacqueline T.O., Global Chief Digital Officer at HGC, Alex Schlager, Cybersecurity CPO at Verizon, and Paul Lewis, Global CTO, Board Advisor, and Educator. Welcome to all of you. And we'll start our webinar with a brief introduction from Hub Security CTO Andrei Iaremenko on today's discussion topics, and then our panelists will each get the chance to introduce themselves and with expertise. After, we'll get into a bit of a deeper discussion on everything related to edge computing, 5G, and cybersecurity. At the end, we'll hold a short Q&A to wrap everything up. So if you have any questions throughout the discussion, feel free to drop them in the Q&A section below, like I've mentioned, and we will get to them at the end. We have an impressive lineup of panelists tonight, and I'm excited to have them introduce themselves to you. Maybe we'll just go one by one, starting with Jacqueline, followed by Alex, who will still join us, has yet to join us, and then Paul. But first, we'll begin with a few words from Andrei. I'd just like to introduce Andrei really quickly. Before that, hello, Andrei.
Hi, Shterny. Hello. Glad to meet you all.
Andrei Iaremenko is the co-founder and CTO of Hub Security, a military-grade hardware security firm built by ex-IDF 8200 unit security experts. Andrei has a vast technological background in software and hardware development and specializes in the architecture of complex software and hardware systems. During his 13 years of service in the IDF's 8200 elite unit, Andrei gained rich experience in managing RF design and manufacturing, boards, embedded programming, FPGA design, hardware design and implementation. We're so glad that you could be here with us today, Andrei. Welcome.
Thank you, Shterny. Thanks for the warm introduction.
Would you like to share a few words about today's discussion topic and maybe what we can expect to hear?
Yes, definitely. So I think the 5G and edge is a very, very exciting and hot topic today for many perspectives. And our today's speakers each represent a different perspective and different view of this huge and constantly evolving topic, both 5G and both edge, which connect together. And we are going to discuss, I think, today many different questions and many views on what 5G brings to the world, brings to businesses, to enterprises. One from the security perspective, and also from the functionality and improvements to the different types of applications, different types of businesses, and also how it comes together, the security, the privacy, the functional improvements, and also what new and exciting things we can do with these technologies by combining also the very fast communication, the 5G and the edge devices that are getting smarter and smarter and doing much more things today than even a few years ago.
Definitely, I'm looking forward to it. Next, I'd like to have introduced Jacqueline. Hello, Alex. Thank you for joining. Next, I want to have Jacqueline introduce herself, and then Alex, you can introduce yourself as well. And Paul, let's try to keep it short because we have a long discussion ahead of us, but maybe you could just give us a few brief sentences about who you are, what you do, and why you're here today. Jacqueline, you're muted.
Sorry about that. Good morning, good afternoon, and good evening, everyone. I am Jacqueline. I am the Chief Digital Officer for HGC Global Communications. The whole topic of edge, 5G, AI, cybersecurity is very close to our heart. We are a fixed line operator located in Asia. where the edge and edge technologies are growing rapidly because of our growing population that has had to do a lot of remote working, and so the amount of demand of content, applications, and transactions in a very distributed fashion is growing rapidly in Asia. So it's absolutely a space that HGC is in at the moment, and investing a lot of time, effort, intelligence, and resources in. So very glad to be here.
We're glad that you can be here with us today. Alex, you're next.
Hey, good morning, good afternoon. Thank you for having me. Alex Schlager. I'm the Chief Product Officer for Cybersecurity at Verizon, for the Verizon Business Group in particular. And as you can imagine, 5G is what keeps us awake at night and keeps us quite busy. The rollout is in full motion in the US. From a security perspective, this represents new challenges, but also new opportunities. So looking forward to the discussion today. Thank you.
Thank you too. Thank you for being here. Paul.
Lewis, I am a CTO and CIO, and I spend on just operating IT and managing, large teams about how the workloads extend to the edge and what the security of the data, both consumption and creation, is going to be. And
Great, thank you. I think your sound was cutting out, but I'm not sure if that was just me.
For me.
Yeah, Andrei, did you hear that as well?
Yeah, it was cutting out for me also.
Okay. Okay, so maybe we can try to troubleshoot that. But maybe we will just start and get into the discussion. Start the discussion and get things rolling because we have a lot of ground to cover. And I guess I wanted to start off with Paul, just to give you the first question, which is just what are some industry examples and values of the use of IoT, Edge, and 5G?
So lots of great examples. Can you hear me?
In and out. Yeah.
Okay, unfortunately. Okay, so lots of great the most obvious one in 5G or the edge production plants, right? Where you have digital twins of full production lines, and you can actually introduce change digitally before physically in those worlds. That extends to things like cities, where I would have 5G for things like parking meters or lights or cameras. And I can redirect things like 911 resources. That would extend to things like oil fields and oil rigs, where I could have a digital oil rig implementation. And I can think about health and safety out in the middle of the ocean as compared to on land. And that would extend to things like lights out mines and lights out construction sites, where I can control the physical equipment without actually having any people involved. And that goes to the real sense of the value of Edge and 5G, where it's about a new human, even so, diagnosis within healthcare, right? Within the actual hospital settings itself, where I can have a real different interaction between an MRI machine and an individual person. Edge security is all extended into this human machine interface.
Great, thank you. I think that, definitely, doesn't cover all the case examples that we can give, but it covered enough of them, I think, to show the importance of the applied use case. And Alex, and I guess my next question would be for you, which is, what do you believe are the biggest security challenges that are related to the adoption of 5G technology and mobile edge computing?
There's a lot of challenges, but I think detection and response. So our ability to detect attacks, threats, breaches, in near real time, and to respond to them accordingly. And the reason is, if you look at past security incidents and breaches, they fell into a couple of categories. Most of them did not affect, everyday everyday people, consumers, normal citizens, whether it's state-sponsored espionage or whether it's a financially motivated attacks against companies. They're bad, but you and me would not normally be affected by such attacks unless our individual privacy would have been violated. Now with 5G and the use cases that we will see, that picture changes because we will see autonomous driving being enabled by 5G and mobile edge compute. We will have smart community capabilities, mobile healthcare, I think was just mentioned. So here the potential impact and the risk as a result of breach and an attack, simply a denial of service attack to the information your car needs to perform in an autonomous way, for example. Here the potential impacts to you and me, an everyday consumer, are significantly higher and can be severe. So as the risk increases for, as I said, consumers and everyday citizens, it's really important from a technology perspective that we have the ability at the edge, near real time, to detect attacks and respond accordingly.
Definitely, and I think that we'll get maybe more into detail about that later on in the discussion. My next question here is for Jacqueline, which is, what are the drivers for AI on the edge in a post-pandemic economy? What does the new normal look like?
A good question. Look, if I continue the line of discussion from 5G, I think in several ways, right? With 5G, what you find is a very distributed mesh network, and with that, you have a lot of workloads constantly going over a very distributed hub model, right? Hub and spoke model. So when you look at Edge AI, you think about what is Edge AI? It is literally a system where you have, I would say in this case, machine learning algorithms that process data generated by the hardware device at the edge. And in this case, maybe 5G handsets or IoT capable of Wi-Fi 6 or 5G, right? So the more you have that, one of the biggest users, I think, as we move into the 5G era, is that you're going to have to need a lot more intelligence of processing these workloads across a 5G mesh, because you don't want to attach the same importance of every workload across this across your mesh, right? So the rise of things like just simply the rise of intent-based networking, where it's more application aware, where it's more workload aware, where it's more needs and transactional aware, right? So what is actually required to process what in what time span? And I think you'll find that those may be very well the first users of AI within the 5G realm. When you look then at that next set of what's gonna create more urgency for Edge AI. I mean, right now you've got a lot of autonomous vehicles testing, right? Things like facial recognition, out on security devices or IoT devices or smart lampposts. That is already an example of AI on the edge. But when you then talk about, what's coming post-pandemic, right? Where there's going to be a lot more remote and distributed connections. I would say next level of it would probably in something like precision monitoring, right? Something that is going to affect all of us as consumers. So precision monitoring, which is really understanding what is alerting out of what sort of device and in which way do you actually respond to it in the most appropriate manner. So not everything is going to be the same. Not every cybersecurity breach is going to be treated differently, because if you do that, it as an operator, as a provider of these sorts of devices, it is going to be operationally cost prohibitive. So you want a lot of intelligence in the way you manage and operate this. And I think that will be possibly the next set of use cases you see in AI Edge.
Great, thank you. I mean, this was going to be my next question, which was, what are the initial, what will be the initial adoption of 5G and edge and computing applications? But think you've answered that a bit now. And how do we see that it's already being used currently? In which industries? Let me rephrase the question. Maybe which industries do you see it really growing in? Because there are already technologies that are being applied in some way. So it'd be interesting to maybe get your insights on some forecasts about where it's heading.
Sorry, for me?
Yep.
Oh, in which industries will we see it? I have to say, during the pandemic, I actually would have liked to see the healthcare industry make a whole lot more use of it, right? In that the need for social distancing, the need for high intensity patient care without the ability to give care would actually drive the healthcare industry to adopt more edge applications, more edge compute type use cases. That I think maybe the health industry was caught out by the pandemic and it had other issues on its hand, really. But I think as you come post-pandemic, I would say, the health industry would probably take a long, hard look at itself and probably move towards more of those sorts of tools and applications where it can provide that sort of care. And you see it already. There's a lot of digital health providers. That's the next wave of, this new normal of digital health that's coming through at the moment. I think the other thing that will happen because of social distancing, you'll see a lot of different types of, I'm going to say, logistics and transport type use cases. And that will be things where, for example, short-lived perishables cannot, need to be preserved. So the amount of sensors that you would have on those sorts of things where, distance is now a lot greater because people aren't coming into central zones to purchase things, to do retail and things like that. So the distance of logistics and supply chain actually grows, but your supply chain actually has to shrink. So the amount of sensors, the amount of monitoring, I think that would possibly be that next set of use cases. And then you think about all that mobility around, I would say, the how should I say, the urgency. And I certainly hope Verizon accelerates, its 5G rollout, because the ability to support that sort of mobility and constant, sort of traffic back to central hub spot if and when you need would actually be really useful in those sorts of use cases.
Agreed. Paul, why don't you give us the data angle here? What are the considerations for both collecting and consuming data at the edge?
Sure. So I agree with Jacqueline and all her examples on where sort of 5G and edge will sort of take place first. And I'd also add, just before I answer that question, you'll likely see the richness come in the asset. There's physical vehicles or assets within a distribution plant or wheelchairs in a hospital, right? It's about finding where they are and where the inventory is, where they are, where they need to be, get lost, right? All of those kind of things. It's about collecting means and bringing that information back versus AI, where those trucks are automatically driving themselves from distribution plant to store, right? And I also think on 5G, there'll be a pretty significant implementation of private 5G. So think of a large distribution plant where it's multiple buildings and multiple stores across those buildings, and I need round before it gets to the stores. I think that's where a lot of that sort of work will be implemented, and I can implement within my control. It effectively replaces Wi-Fi in many ways. But back to the data. Working from home equals working from anywhere, and working from anywhere also equals services from anywhere. So just imagine it used to, thousands of us went to the office and we used to. Now there's millions of people at home acquiring goods and millions of people at home servicing goods, which really just means Data is both consumed and created now at the edge, not in a sense. I have to worry about its security, its governance, its protection, its data lifecycle. All of those things are now worries at the edge, and now I have to extend all of my cybersecurity concerns, my IPS and my IDS and my internal penetration now has to think about a federated penetration world, right? Especially more difficult now that it's not just information workers at home, it's task workers at home, it's frontline workers at home, none of which have ever received, let's say, cybersecurity training, right? All of which at home from a bad guy and think it's actually IT because bad guys can't possibly know my home phone number, right? So I've implications of the data angle when data is now federated across millions and millions and millions in my own firewall.
Right, and I think it's a really important point that you bring up that many employees are not educated in cybersecurity protection and prevention, and this is why we've seen a rise in ransomware attacks. People are clicking links. Phishing attacks have been really successful at targeting employees at really critical organizations, even within critical infrastructure. This is definitely something that I think many people are taking notes on.
Yeah, they're definitely more bad guys, better at what they do, and more precise in the kind of data they're trying to obtain.
Right, exactly. Alex, my next question is for you. How much do you believe will risk-based approaches to cybersecurity play a role in 5G and MEC?
I think a lot. And, I think this is one of the many positive developments we have seen over the last probably 2 to 3 years, that security has become not only, a technology race and trying to throw the latest technology at the problem and hoping it's good enough, but you saw a lot of work and effort being put into creating outcomes with security. And that outcome is a true understanding and the ability to quantify risk versus the security posture that an enterprise, for example, is having in place. And this ties to some degree to your earlier question. When I talked about 5G use cases, I think this is where this will basically converge and come together as we try to measure and quantify outcomes we create with security technology and solutions. I think 5G use cases will be a great application for that. Meaning, I mentioned before autonomous driving. So the potential risk of not properly securing an autonomous driving ecosystem, is obviously very different than, let's say, a breach of an edge-enabled gaming environment, right? One is inconvenient and the gamer might be upset, versus the other could actually harm human life and human health. So this is just one example where you have very different risk very different risk outcomes on the spectrum between convenience and actual, danger to human life. And I believe that as we look at these 5G use cases, it's a great example to it's a great opportunity to work backwards. So really start with the risk, start with a deep understanding and analysis of what is the worst possible outcome if one of these environments gets breached, and then work backwards in sense of what is the required security posture, security technology. I mentioned managed detection and response before, that should be and has to be applied to these use cases. So what you will see with 5G security is a highly modular stack of capabilities that start all the way at the radio access level as 5G itself. It's covered in the 3GPP standard, sees a lot of new security capabilities and features already on the radio access level and on the transport layer, all the way up, as I mentioned, into detection and response. So, these building blocks, these Lego blocks, if you like, will help us to, assemble the right security posture compared to the risk a specific use case represents.
Do you think that we will also see a broad adoption of zero trust policies?
Oh yeah, I mean, look, zero trust is the new norm, if you ask me, or should be the new norm. Again, go back, I always like go back, in time to look at how security has, evolved over time. If you go back 3-4 years, the dominant paradigm was still protect the perimeter and trust everything that is inside the perimeter. There is no perimeter, right? The perimeter is gone. It's gone, and 5G and mobile edge compute are even further accelerating the dissolvement of the perimeter. Therefore, zero trust has to be the new norm, meaning, the concept of least privilege, the concept of my default stance is I don't trust, and every interaction has on that basis. And again, incorporated in the 3GPP standard. So a lot of interactions that happen on the radio access network transport layer in 5G are based on that principle. And the security stacks that we and others are building basically extend that concept all the way up, first to layer 3. So we have the first solutions in place that deploy zero trust on the network layer, on layer 3. And then all the way up to the application layer, meaning you will see it, as I said, on the transport, on the network layer, you'll see it in machine-to-machine environments, but we're also seeing it in form of software-defined perimeter as, ultimately a consumer or home, working from home tool that replaces legacy VPNs as we know it from the past.
Definitely. Thank you so much. Paul, in terms of edge computing, you touched briefly on edge being the new cloud. Can you expand on that a bit for us? And is that part of a diversification model that's being applied?
So good question. We've been, especially in this conversation, but we tend to forget that edge is part of a much bigger sort of only use cases. Edge has to play in the rest of a complex transaction set, right? The reality is it's not just an application that sits on the edge, but it's also that application has a data center, which likely is processing in our client.
Wow, Paul, we're having a really hard time hearing you. For some reason, your mic keeps cutting out. Are you using an external mic? No. Okay. I'm not sure. Okay, well, maybe just continue. We will get the bits and pieces that are important.
So yes, diversification is what a CIO and CTO needs to. It's not just all the federated applications created inside the organization, like a cloud or problem versus a single one that's at sort of conversion together, convergence.
Great, thank you. We're going to, I'm going to ask my final question, and then we're going to head into Q&A. Unless anybody else has anything else to say or to contribute after Andrei's question, of course, we can continue the discussion. But just for the audience, if you have questions for specific attendees, send them and specify who they're for, and we will get to them at the end.
Shterny, can I offer an alternative opinion to what Alex and Paul has just said? I think, yeah. Well, when we talk about the issue of data and security, right? Let me offer an alternate opinion. I think one of the advantages of edge is that there is actually an inherent increase in the level of security in terms of data privacy, because data is actually produced and maintained on the edge. And actually where you deploy your models is to the edge. It actually doesn't, you actually eliminate the need to actually backhaul your data processing. It's actually all done on the edge, right? So it doesn't actually work like a cloud type model anymore. There is no backhaul back into a central zone or even a hub zone anymore. And that is one of the beauties of edge and edge security. So I think when you look then at edge technology devices, right, which is the next generation of devices coming out, there is no need to actually have it maintained by data scientists or AI developers. Is actually all done on that device. And I think actually where you'll find that next thinking of edge is in three places. One is that rather than zero trust, I think before you get to zero trust, the leap into a micro-segmentation of one becomes a reality. So today on network, we have micro-segmentation, right? But they are still networked and I'm going to say centralized type devices. So they're still designed around that. I think where you see edge going in cybersecurity is going to be micro-segmentation of one, right, which is around that device itself. And where you get a lot of runaway on security is where people, right, who think they're IT guys or security guys, they put this device amongst their own set of devices and then start connecting it up. And without the proper design of a segmentation of one, right? So you can have zero trust on a Siri, but as long as you connect it to everything else that doesn't conform to the same standards, you are still going to be exposed to some sort of risk. So I think the first area where we're going to see change in architectural and design direction is in that micro-segmentation of one. Okay, that's the first bit. The second area I think is that today applications, when we went from an on-prem type architecture and design, it then became a cloud native or SaaS type architecture and design. I think very shortly, and you see a lot of application and software houses moving to that, you're going to have edge native design. So today, if you had to deploy an application to design, by default, you would still have to deploy it out of central. It doesn't live naturally on the edge, such as data would. It's just that data is living on the edge. But at some point in time, we would, as the technology community, actually have to start creating edge native applications, right? And that would actually make your compute a lot more secure and a lot more built for the edge. The applications that we have today aren't exactly built for the edge. The third area, I think, where we will see a lot of advances is in the storage on the edge. So you don't need a lot of storage on the edge, but when you run AI modules, they tend to chew up GPUs, right? So when you run them out of a centralized architecture, they tend to chew up GPUs. And deploying AI to the edge isn't really that simple because these models run on base data and base assumptions, right? So you can't just deploy data to the edge and say, oh, you just use that data and you'll figure it out. Doesn't kind of work that way. Still has to make reference to, I'm going to say reference data, if you like. So Google and people like that have actually now created, TPUs and things like that for the edge, specifically for the edge. So I think where you see that next movement in the technology industry is really about thinking of cost-effective storage, if you like, on the edge. So it's just an alternative, an extension of what the gentlemen have said.
I'd like to caveat, if I may, a couple of your comments. So I don't disagree. I just, would like to perspective on a couple of things you said. So, first of all, the way we deploy edge compute is all about cloud. So, you might know that we work very closely with AWS, and the way we operate the edge environment is basically cloud infrastructure, right? Technically, it's wavelength, formerly known as Outpost. So that is a cloud environment. The second thing is, and you referenced to it, these edge mini data centers, they're very constrained in space, right? Because there's a high amount of them. We have to get very close to our end consumers because we would like to utilize the millimeter wave band. But this means we have to get closer. And this also means these data centers where we run edge compute become significantly smaller. And that space constraint means that there will be backhaul into a back-end cloud environment. So there are workloads that will be autonomous at the edge, but there will be a large amount of workloads that require the backhaul into respective cloud environments. I fully agree on your comment on specialized, silicon and microservices to run analytics at the edge. We have seen this also at reInvent, AWS announcing that. So, it will be interesting to see how this evolves. And, I guess that in different countries and regions, we will see different permutations of that. And the last thing, zero trust itself at layer 3 creates what we call IP enclaves. So technically, it would perform as a network segmentation function. So that's at least the way we look at it in sense of, segmenting on an IP basis with encrypted payload, and extending that capability even to protect between wavelength zones or even within containers, within Kubernetes containers, for example. But, it's early days and we will see where the road is heading.
Thank you, Alex. Jacqueline, do you want to respond to this? Or Paul, do you have anything to contribute?
My only addition would be to appreciate sort of the complexities of an enterprise, right? So while it's true that one to run sort of an analytical or data collection process at the edge or empower an edge machine, for corporate enterprise data that needs to come back to the core or to the cloud for the purpose of data protection, for the purpose of a variety of enterprise-wide governance. So it can't just be at the edge in all practical sense, especially if the edge is in fact right? If it's desktops, laptops actually producing and consuming content, yes, if I'm doing data science at home, I in fact have to grab data from the core into my edge, determine what the attributes are, do data quality, and send that data back, right? So it's not just an edge-only conversation in the enterprise world.
Yeah, thank you, Paul. Jacqueline, did you want to respond to any of the
I think what Alex and Paul have said is really about where we are today. What I'm talking about is where this will go. You're talking about post-pandemic, right? I'm talking about where we will go very, very rapidly in the next stage. And I appreciate what we're talking about in terms of treating each edge of the network, but that's exactly what I'm saying. Today we treat it as a network in its own right. We treat it as a specific device, as part of a wider cloud architecture in its own right. What I'm suggesting is that, yeah, that is true for how we think and how we architecture today. In the near future, that thinking will change very rapidly in the post-pandemic world, because that spread of cloud and treating edge as another extension of cloud, that architecture and design will change in that post-pandemic world. I have no doubt that edge devices or not necessarily DC edge, but it's talked about IoTs and edge devices, they will start getting treated as segments of one, micro segments by themselves. Would we then need to backhaul data all the way back to a central point? That may be so. However, as I said, your architecture and design in the near future or in the future would have to change as to how and why and where you do it and what for. Does it contribute to your bigger AI model, and why should it if your AI model is actually deployed down to the edge where it is actually running a segment of one? So what I'm saying is, yeah, everything that Alex and Paul has said, yeah, I agree with, because that is where we are today with what we have. What I'm suggesting to you is in the future, in the near future, that design and architecture, or that architecture and design will necessarily have to change. If you look at the way autonomous vehicles are going, autonomous vehicles run as an edge on themselves. If you look at what Tesla is testing at the moment, it does not, that does not backhaul its data all the way back to central. It's running within that vehicle.
Yeah, I think that's a really good case example. Andrei, I guess I'm going to maybe pause this specific discussion because I want to make sure that we have time for Q&A. So Andrei, I'm just going to ask you, as we're discussing, a large part of critical infrastructure OT is on the edge of organizational networks. And cellular technology became an enabler and accelerator for connecting all these physical real-world devices to the internet and the cloud. From a security standpoint, what is your recommended approach when it comes to connecting OT systems to the cloud, and what are some steps that organizations can take already in order to ensure that they're protected? I think you're muted.
About this. Oh, can you hear me now?
Yeah.
Okay, so actually, start from great examples from Jacqueline, Alex, and Paul, when they mentioned healthcare and autonomous cars and smart city sensors. So OT, the operational technology, it's becoming ubiquitous. So it's not only the controllers and the power stations like a few years back, it's every sensor, every device, autonomous device that is now being tied into the network to the internet. And the thing is that there are a huge variety of devices and manufacturers, and everybody is running towards making devices and sensors cheaper and faster, and doing AI on the edge with special processors, and doing more applications, and doing more smart things. And the majority of them are not concerned about security when manufacturing and selling devices. So it's probably the more, from my perspective, flexible approach to security is to wrap the sensors with the additional security layers, so that on the one hand, we can get all this great functionality and the acceleration of AI on the edge. And we don't have to choose between the security and the application performance, or what they can do. So maybe the best approach is adding the security also in software and also in the hardware level, because the software today is not enough. We are seeing that hackers very easily overcome the software protections, even for the data centers, and definitely so for edge devices with limited performance and memory for the security functions. So it's adding the security to any kind of sensor or any kind of device, because we need it today. We need today the privacy, we need today the security for the whole existing infrastructure that is being connected to the network, to the internet, and to the cloud, and between themselves. As there is no time to wait for several years until the new generation of devices are going to have a baked-in extremely high security.
Definitely. Yes, thank you. And I think this is why the work that HubSecurity is doing with their HSM devices is really important. If you want to talk about that a bit, maybe just in a sentence or two, and then we can move on to Q&A. So just to remind our audience, if you have questions, send them. Now's the time, get them in. Andrei.
Yeah, so that's actually the approach that we're taking with in HubSecurity, is providing a platform that can be added both to the existing devices, existing systems on the edge, if it's smart car and if it's a camera and if it's sensors in the power network, for example. And then it adds all the security of physical security and network security to the existing installations. So the network runs as is, and the newer generation of encryption and authentication, including the quantum resistant quantum proof algorithms, can be added very easily without any disruption to the existing infrastructure. So that's on the one hand. And not everything can be done on the edge, I think, today and even in the future, as there is also large advantage to doing things centrally in the cloud, in the big data centers. And there also, it's basically the same need, how to secure an applications that are running and processing very sensitive private data and needs to be regulated. And so it's the same principle from our standpoint as on the edge, the same in the data center, to wrap the application, the code, the data in a full stack hardware and software based secure enclaves. So our clients can continue running as is without any changes, and the hackers are automatically stopped before they get into the application.
Yeah, super relevant especially for the current landscape that we're in. Thank you, Andrei. I'd like to now move on to the Q&A. We don't have a lot of time. We have about 10 minutes. And so I'll just shoot them off. And some of them are for specific panelists, but no, none of them are. They're pretty open-ended, actually. So I will just throw them out. And if you want to respond, you can let me know. So we have one here from Igor, who asks, does Open RAN concept implementation have a perspective to become a widely used platform for edge computing? Anyone want to jump in on that? Oh, no takers. Okay.
Could you repeat the question?
Sure. Does Open RAN concept implementation have a perspective to become a wide? But I'll share it also in the chat so you can see it.
Open RAN.
I'll give it a try, and I have to admit I'm not a radio access network specialist, so please take it with a pinch of salt. What I do understand is that the 3GPP standard that I was referring to before gives us the ability to exchange significant more information across carriers in sense of the Open RAN. As if we have a subscriber from a different carrier, roaming via the Verizon network, for example, we still have the ability to understand who that subscriber is, to authenticate to this subscriber, and therefore this will have positive, implications to edge compute in sense of understanding already at the radio access level, how the user has been authenticated, who the user is, and where the user is ultimately coming from, either from a roaming network perspective or even a geographical perspective. I'm not sure this is what the question was aiming at, but that's what I'll take away from it. Thank you.
Thanks, Alex. Igor says thank you, so I think maybe we did answer it. Jacqueline, did you want to contribute anything to that, or no? Okay. So moving on to the next question we have here for Jacqueline, Paul, and Alex. Would you like to comment on private 5G network possibilities or potential? Jacqueline, Paul.
Oh, okay. Why don't I give it a go, and maybe Paul and Alex can jump in. I think if I interpret the question, actually, it was something I thought it was Paul that mentioned it, that that he was seeing actually, you know, quite a big increase in the amount of private 5G networks. I would say over here in Asia, as spectrum is getting released, so I think it was yesterday or the other day, Indonesia just had its first allocation of 5G spectrum as well. It's quite interesting. As much as consumer 5G you know, has hit the market first, what we're seeing in the enterprise space is actually a lot of private 5G demands. And you know, the first ones that have actually asked us for this is actually government networks. So where government has to have secure, I'm going to say secure networks and secure connectivity over, I'm going to say, a sensitive transmission across secure government departments. So that's the first area we're seeing it in. Second area we've seen it in is, I'm going to say, government related type enterprises. So things like airports, for example. We've seen quite a big demand for private 5G networks running over airports. Of course, in the current pandemic situation, that need have subsided. But just before the pandemic hit, you know, there was quite a big push to actually run those over those sorts of enterprises. I don't know if Paul has anything to add to that.
I agree. In fact, with government and transportation, especially an airport, where very wide space with multiple outbuildings that need to communicate in real time in many ways back to the front, right? If I'm worrying about and traffic on the runways, and in fact traffic at the gates, that is a complex series of communications, and this is the perfect way to sort of implement that internal communication pattern. And then government in the secure communications across buildings, and even within cities, secure communications. So I'm seeing a lot of that on the enterprise side. I agree.
Thank you, Paul. Alex, you wanted to jump in?
No, thank you. I think Jacqueline and Paul really summarized it well. Thank you.
Great. So we're going to move on to our last question here, which is a bit long, so bear with me. I will share it also in the so everybody can see it. There are some countries like Switzerland where there is still an ongoing discussion around the safety of 5G and especially millimeter waves. In your opinion, is this a discussion that is basically unnecessary as research is solid enough to allow the assumption that there are no health implications to be expected? Or is it still a discussion that you think is relevant to be had? And if so, who should be responsible? I'm not sure if this is necessarily a the question for cybersecurity experts or health professionals or conspiracy theorists, but you can give us a little bit of insight or add to the discussion somehow.
I'll get it started and then ask Jacqueline and Paul for their opinion. Look, first of all, yeah, every discussion should be had, right? In general, we should have discussions, and it's always good to be cautious. I would just remind that we had these fears with every single introduction of this new cellular technology. So we had the same, to some degree, conspiracy theories and concerns with 4G, with 3G. So this is not necessarily new. I also would like to point out that 5G is not exclusive to the millimeter wave band, meaning the way 5G has been standardized and designed is it works on different bands. So on the C band, for example, and we have had the C band in use for many, many years, and no health implications to my knowledge, have arisen to that. So ultimately, we have to rely to a degree on the FCC in the US or on regulatory bodies that will, attest how safe a technology is, as much as we, rely on health agencies as to whether the COVID-19 vaccine is healthy, is safe, for example. So again, always good to have a discussion, but I think, I think it's safe to say that the technology is safe. But I'm not a medical professional, of course.
You're not going to grow a third arm?
Might come in handy.
Might come in handy. Okay, great. Unless Jacqueline and Paul had something more to contribute. I just want to say thank you everybody for your vast insights and for joining us today. This was a really wonderful discussion. And they're really interesting topics. They're all emerging, and they're all related to emerging security challenges. And so there needs to be ongoing discourse and continued discourse around their implications. So I'm really glad that we got the time to flesh them out together. I'd also like to just thank Andrei Iaremenko for joining us from HubSecurity. Thank you for your insights as well. And we hope that you're staying safe and healthy at home, and we look forward to holding many more discussions like these. If you want to get in touch or learn more about the work that each of our panelists is doing, it will be included in an email that you will receive after the webinar with some contact information. So if you want to get in touch, if you have follow-up questions, or if you just want to make a connection, feel free to do that. To stay up to date on our upcoming webinars, you can follow us on HubSecurity on LinkedIn and also on Twitter. And I write a short digest weekly on Medium. You can keep up with top stories coming out of the cybersphere there too. Jacqueline, Paul, Alex, anything else that you'd like to share?
Thanks for having us. Appreciate it. It was a great conversation.
Definitely.
Thank you.
Definitely.
Yeah, thank you. Hope everyone got something out of it.
I think so. I hope so, definitely. And you'll be able to find this video on YouTube. It's recorded and you can share it with your friends and family, whoever is interested, really. Thank you guys so much again once more. And I hope you guys are all staying safe and that you have a happy Hanukkah and a Merry Christmas.